Hello everyone, my name is Do Kyung Kim, who is currently working with the Marine Offshore Subsea Technology Group at Newcastle University. And first of all, I would appreciate Mr. Chairman, Professor Sun Jun Kim, who has prepared a lot for this session. And this is the first session, Innovative Material Engineering and Technology. And today I'm going to talk about the condition assessment of the shore structures by damage index concept. So basically, the shore represents the onshore, offshore, or the near shore, including the ship structures. And as you can see the title, I'd like to briefly introduce about how we're going to handle the structurally damaged structures for the condition assessment. So let's get it started. So this is the overview of my presentation and the background and aims, followed by the procedure for the condition assessment of the damaged structures. And we need to identify the damage type and analysis method, and the modeling technique for the damaged structure might be important. And the applied example may be quite useful for us to verify the proposed concept and conclusion. So the first part is the background and aims. So as you can see here, nowadays, the key issues for the operating infrastructures, always we talk about the health or the human and the safety matters and the environmental issues, we call the HSE. So in our field, the ships and offshore industry, of course, HSE is a priority. At the same time, we discuss about the environmental issues like green cruise, green shipping, and etc. And especially here in UK, we always talk about how we're gonna reduce the emission by 2050s. At the same time, without energy, we can't stay. So resources are pretty much important for us. So in the case of ship structure, I'd like to highlight about the advantage of the ship structures. So as you can see here, the left top box, and they talk about the CO2 emissions. And of course, our ship structures are a much better option than the rail or the road or the airplane delivering the cargo options. And in terms of the energy consumptions, of course, the shipping is the best option. And they have compared the individual options, including different types of the vessels. But despite of these, advantages, our field, the shipping industry engineers, we are always talking about how we're gonna minimize and optimize the greenhouse gases emissions by 2050s. So that is the current situation. And I'd like to introduce about the damage type or the nonlinear structural consequences, including the geometric and material nonlinearities. So shipping industry or the offshore industry always, it is not always happening, but once the damage or the accident happened, we need to put a number of effort about the HSE. So for example, the fire, especially here, fire accident or the explosion, actually fire and explosions are one set. And of course, during the operation, we can experience the collision or the grounding or the dropped object during the operation, or as time goes by, our structure should be, aged. So aging issues, for example, the corrosion issues, fatigue cracking, or the localized dent, etc. So of course, during the construction, we can face it. You can face the initial imperfection issues during the operation, the abnormal wave or the dynamic pressure, the low temperature, especially the LNG, or nowadays we talk about the liquefied hydrogen issues, so cryogenic conditions as well. But today I'd like to talk about the accident case, and especially the grounding case will be highlighted. So this is the target, the grounded ship, not the cruise ship, but you can see the photo. So procedures for the condition assessment of the damaged structures. Of course, I will show you what is the general procedure and current regulations and the guidelines. and I will highlight the proposed method and the applied examples. So this is the general procedures. We need to firstly define the structural characteristics, and of course the damage should be identified by determining the damage amount and the location or the type. And based on the gathered information, we can do the structural modeling, the damage modeling, and based on that, we need to calculate the remaining strengths of the structural capacity. And after that, we can do the condition assessment of the damaged structure. Then we need to take some action. So in our field, the current regulation and the guidelines, we have the International Association of the Classification Societies, including the DMV, the Lloyd Register, or Korean Register, IBS, etc. At the same time, we have the IMO. It is quite famous organizations, and individual industrial regulations existing. So you can see the details here. And this is the proposed method by Pak et al. 2012 and my PhD thesis. So we need to identify define the structural characteristics and characterization of the damage parameters, and the selection of the damage scenario. This is quite important step because it will affect the final outcome. So in our case, we prefer to adopt the probabilistic identification of the damage parameters, and we can't, if we have the enough time, computational or the physical time or the cost, then of course why not, we can adopt more than 100 or the million cases of the damage scenarios, but we better to select the wisely. So sampling technique is needed for us. And after that, we can define the damage index. This is the main, the keyword, the DI for the selected damage scenarios. So based on that, we can calculate the remaining strengths of the damage scenarios. And based on that, we can establish the relationship between the damage index in horizontal axis, and the vertical axis will be the remaining structural capacity. So that we call the RD, residual strengths, and the damage index diagram. So once we establish this kind of diagram, of course, we can simply identify the damaged area, amount, location, and then we can calculate the damage index, substitute to the diagram, and then we can check whether the structural capacity is lower than the criteria or not, isn't it? So first two steps, you can see the sample, the oil tanker, the midship section, and you can see here the rock. And of course, this represents the grounding damage. So of course, we need to define the 4 different parameters like grounding location in the direction of the ship's beam, and the height of the rock penetrating into the bottom, and the breadth of the bottom of the rock, and the elevation corresponding to the ship's baseline, and the breadth of the tips of the rock. And of course, we need to define the angle of the rock. So after that, we can move forward. Selection of damage scenarios. Of course, in IMO, they have provided probabilistic, we call the probability density function, PDF. So based on these 4 parameters, we put it like X1, 2, and 3, and 4. So we brought this PDF and we utilize these for the sampling. So in the case of sampling techniques, there are so many different types of the useful sampling techniques. But in our study, we adopted a Latin hypercube sampling technique. We call the LHS. So efficiently, it will support us to reduce the number of the damage scenarios. So now we selected the damage scenarios. The next step might be the definition of the damage index. So you can see here in this case, we put G in front of the DI because this is the grounding damage index. Anyhow, this single parameter damage index will represent an is the function of the all kind of damage parameters like x1, x2, x3, and 4. So it might be very useful for us. So how to establish this GDI? You can see here the AO and AI. The AO is the outer bottom, and the AI is the inner bottom structure. So this is the inner bottom, and the outer bottom is over there. And at the same time, we need to consider the original area as well as the damaged area. So based on this relationship, we can establish this GDI. And here I have not explained this correction factor. So about this correction factor, we can calculate the residual strength by increasing the damaged area, so that we can see the relationship between the outer bottom, the contribution, as well as the inner bottom contribution. So based on this diagram, we can check the angle and we can get this kind of one single correction factor. So after that, we need to calculate all the damage scenarios in our study. I will show you later in the applied example part. But individual vessel, for example, the oil tanker, we have selected 50 damage scenarios. So in the vessel structures, it's like the simple beam, and it is subjected to the vertical hogging and vertical sagging bending moment. So we need to check the ultimate hogging bending moment, as you can see here. And at the bottom, you can see the ultimate hogging sagging bending moment. So in total, 50 times 2 cases in terms of the hogging and sagging. So we will calculate it. And based on that, we can plot everything here. You can see just a single line, but basically we need to plot all the calculated numerical simulation result. And based on that, we can use the curve fitting so that we can develop the LD diagram representing the residual strength and the damage index diagram. So you can see here the advantage of this RD diagram is based on this GDI definition. We can simply calculate it based on the observed or the measured damage amount, location, and like that. Then once GDI value is calculated, we can substitute it to the LD diagram so that we can check the structural capacity, remaining structural capacity, and we can do the safety assessment in a one shot. So you can see here, we discussed about the general procedure as well as the current regulations and the guidelines examined, and the new method has been introduced. It's like the residual strength and the damage index diagram. So damage identification, there are so many different types of the damage type, but in this study, we want to discuss about the grounding cases. And until now, there are, continuously happening. We can see the grounding or the collision or the other types of the accident. So this is the typical example reported recently in South Korea. And after the collision, the vessel has been broken into 2 pieces. So basically, this is the vessel loss scenarios, and there are so many factors, but at the same time, it is combined and complex phenomenon. You can see this flow chart, and side shell failure, like due to the collision accident, and the bottom shell failure we call the grounding accident. Of course, oil spill or the water ingress will be happening at the same time. As time goes by, this vessel will be aged. So corrosion, fatigue, cracking, localized bend, it should be considered together. So this might be considered as the vessel loss scenarios. And I've shown this overall picture and the damage type, accidental or the in-service or the etc. But in this study, we want to focus on the grounding cases. It doesn't mean that these can be applicable only for the grounding cases, because we have confirmed that this can be used for the collision or the other cases as well. So grounding damage. there are several types of the grounding, but this is the typical shape of the raking damage, which means that this is our vessel and this is continuously moving from here to there, and the rock is here. So this will be, scratched. So raking damage is assumed like left-hand side here, and stranding case is like that, and the water level reduced so that the vessel will be on the rock. So this is the stranding damage. But in this study, we want to discuss about the raking damage only. So of course, we need to select the relevant and the scenarios. So based on this, given the probability density function, we have selected 4 parameters, individual parameters. It's like the grounding damage location, grounding damage height, and the grounding damage breadth, and the rock related the angle methods. So based on this, we adopted the sampling technique, and we generated 50 individual damage scenarios, as you can see here in the box. And damage type regarding the grounding and others are briefly explained here, and the method for establishing the damage amount investigated. So the important keyword was the probabilistic scenario-based approach will be adopted in this study. And in the case of the analysis method, of course, in our field, why not? We can adopt the full FEM, the commercialized software, such as the ANSYS, Abacus, and etc. But as we know, it takes quite a long time, computational cost, the human cost, etc. So in classification societies, they adopt the beam column based the assembly technique. So it is quite efficient, but in terms of the accuracy, it should be discussed further. And in between those two, we also have the ultra large size, the intelligent, the super size finite element method we call the output hole. So it's up to us. We can select either the ANSYS or the output hole or the CSR method. But in this study, we have utilized the ISFEM here. So in the case of grounding damage, of course, we can assume the minor or the major damage. It has been, relevantly selected based on the total 50 damage cases. And in the case of modeling technique, of course, we can adopt the realistic cases, but for the simplification, we just assume that if the rock is here and the vessel is there, and if the rock at the bottom structure is meeting, then we just remove the element that is the technique. Of course, it might overestimating the damage, but it might be helpful for us to move one step forward easily. So apply the example, this might be useful. And this diagram we discussed earlier, so I will skip it. And in this case, we have adopted 4 representing the oil tankers. You can see here, this is the very large crude carrier and the Suezmax class oil tanker, and followed by the Aframax and the Panamax class oil tanker. So based on these 4 structures, the 4 different sides of the oil tankers, we can generate the RD diagram at the end. Of course, it doesn't mean that we can utilize only for those 4 vessels, because we will interpolate it so that in between those 2 sizes or something else, we can consider the all type of the oil tankers. So target structure has been selected, and selected damage scenarios. We discussed about the X1 to X4, about the grounding location and blah, blah, blah. So this is the selected scenarios. Of course, we defined the B, D, and etc. in the previous section here. You can see the detailed parameters based on the selected vessels. So just substitute it, and then we can get individual, the 50 scenarios, and followed by the calculation of the correction factors. So we will reduce the damage inner bottom and the outer bottom area so that we can find the ratio between the inner and the outer bottom. So that is the contribution of the inner bottom structures. After that, we need to calculate and determine the GDI values. So 4 different vessels like Panamax, Aframax, Suezmax, and VLCC, and 50 cases. We have just shown selected cases, but we have calculated all 50 cases, and the hogging and sagging, the vertical hogging and sagging cases. So in total, for one vessel, Panamax, we calculated 100 simulations. So in total, we simulated 400 cases, and one case it might take about 5 minutes. So you can imagine how we simulate the damage scenarios. So development of the RD diagram, you can see here, this is the VLCC case. The horizontal axis is the grounding damage index, and based on the obtained 50 numerical simulation result, we can apply the curve fitting method, so that this is the second order quadratic equation. So it might not be difficult for us to understand it. So at the same time, we put it like the R scale values. So it seems that generally it shows the good agreement with the numerical simulations. In the same way, we put it like this is the hogging, the black color, and the dotted, the red line represent the sagging bending moment case. So in the same way, we plotted the Suezmax and Aframax and the Panamax classes. So based on these obtained outcome, of course, we can generate the plotted all together and differentiate the hogging case and the sagging case as well. So in this case, we also plotted, extract the empirical formulas as well. So you can easily utilize this diagram. Of course, if the vessel size is somehow different, then we need to provide the relevant information for our users. So in terms of the breadth and the H/D ratios, we try to plot it, and we get the best relationship, the R scale values. Of course, we have tried the other parameter like the length or the height, but those two were the best option for us. So this is the upper limit, because IMO represents that if the ultimate limit state or the remaining structure capacity is less than 90% compared to the original conditions, we need to take action immediately. So based on that, we have plotted this kind of upper limit of the GDI. You can see the details. And based on that, in this part, the example studies have been introduced, and in total 400 numerical simulations has been conducted. And based on that, we could be able to achieve the RD diagram. Of course, it can be additionally applied to the corrosion and the grounding cases. We can combine it. You can see here we have investigated in the different paper, but it is possible. Of course, we can consider other types of the damage as well, like the collision or the fire, explosion, etc. So this is the conclusion, and we introduced the condition assessment of the damaged ships and offshore structures or the shore structures. It doesn't matter, because we briefly introduced the how we're gonna handle the damage by adopting the damage index concept. And I think that this can be further considered like the data processing techniques. Nowadays, we always talk about the artificial intelligence or the deep learning, machine learning, reinforced learning. All those things are the functioning as how we're going to handle all the gathered data or the information. So this is one of the way how to handle the data. An innovative method we call the RD diagram has been introduced, and applied example by adopting the applied example, our proposed concept has been verified. So I think that's all for me today. And if you have any question, then you can give me email, send me email, or in the session we can meet. in the future. So thanks very much. Bye-bye.